All right, so we're going to go ahead and start Unit 3. 3.1 is all about complex numbers, which you may or may not have seen before, but we're going to start with that and just kind of look at what they are, how we can add, subtract, multiply, and divide them, okay? So the complex number system is what we refer to when we're talking about imaginary numbers, right? And we get an imaginary number I when we end up with a -1 under a square root. Okay, so anytime we see a -1 under a square root, we want to start by pulling that out as an I, okay? And notice if we pull that -1 out of the square root, we're left with just like a +1, right? And the square root of +1 is just 1. So we end up with 1I, which is then just I, okay? The other thing we need to know is that if I is equal to the square root of -1, then if we were to square both sides, that means I squared equals -1. It's the only time we can square a number and get a negative, right? So this is something we're going to have to remember. Okay, we want to make sure we know that I squared equals -1, because what this tells us is that we should never end up with an I or a power of I larger than the first power, because if we have a squared or anything higher, we should be able to simplify it because I squared equals -1. Okay, so let's go ahead and look at some examples. If we have square root of -7, before we do anything else, we want to go ahead and pull that negative out as an I. And then if we can simplify the radical, we want to go ahead and do so. Here, 7 is a prime number, so there's nothing more I can do to simplify it. So this would be my solution. Now, in my math lab, it might have you write it as the square root of 7 with the I at the end. I prefer this notation, but if it won't let you put it in front, you can put it behind. It means the same thing. Just make sure when you're entering it in the box, in my math lab, you move that cursor outside of the square root before you type your I, okay? All right, same thing on this one. Now this one, we don't want to say double negatives gives us a positive, because notice this negative is under the radical, which means that it needs to come out as an I. So we have the negative that was already out there, the I that we brought out, and now we are left with a positive square root of 64, okay, or square root of +64. And then that we know is a perfect square. That's just 8. So this just becomes -8I. And we leave it like that, okay? All right, with square root of -48, again, we want to take that negative out as the I first. So that gives us I square root of 48. And then we want to try and simplify this any way that we can, okay? 48 is the same thing as 4 times 12, right? And 12 is 4 times 3. So notice here I have 2 copies of a number, right, which is a perfect square under a square root. So that means that number comes out and whatever I'm left with stays underneath. So this just becomes the 4 that I brought out, the I that I brought out, and then the 3 that I was left with under the radical. Okay. Again, my math lab may have you enter this as 4 square root of 3 with the I at the end. Okay. Both are completely correct. All right. So go ahead and pause the video real quick and give these 3 practice problems a go. And then when you're ready, unpause it and we'll see how you did. All right, so on the first one, all you can do is pull out the I. You have the negative that was out front, the I that you pulled out, and the square root of 13 doesn't simplify, so we just leave it like that, okay? On the second one, we can pull out the I. There was a negative already there, so it stays. The negative from underneath the radical became an I, and then we need to simplify 32. Now, I broke it down with 4s. If you broke it down even further into 2s, you probably were able to pull out more little copies of smaller numbers. But either way, you should end up with -4I square root of 2 or -4 square root of 2 with I at the end. Okay. And then the last one, when we bring out the negative as an I, we can simplify the square root of 4 to be 2. So we should just end up with 2I. Okay. All right. So now let's move on. Now that we know how to simplify complex numbers, now let's look at adding and subtracting. Okay. Adding and subtracting is the same as adding and subtracting like terms. Okay, if it has an I, you can combine it with something else that has an I. If it doesn't have an I, you can't combine it with something that does have an I, right? And we want to make sure that we always write our complex numbers in the form A plus BI, meaning we have our real number part plus our I part, okay? If either of those is 0, you don't have to write a 0 in, but if we have two distinct terms, we want to make sure they're separated. Okay. All right. So add and subtract as indicated. We're going to go ahead and distribute this negative first. So I distribute the negative. So that's going to give me the 2 minus 3i from the first quantity. And nothing's being done there. So I can just drop the parentheses. Here, this is going to become a positive 4 and a negative 6i. And now I just combine like terms, right? Negative, or sorry, 2 and 4 gives me 6. And negative 3i and negative 6i gives me negative 9i. And we just leave it like that. So you can see we have a distinct real number term and a distinct complex or imaginary term. Okay. This one's the same thing. The only difference is we need to simplify before we start adding. Okay. So in here, the 2 can stay the same. The negative is still there, but I need to simplify this, right? This negative is going to come out as an I, and then once I do that, the square root of 4 I can simplify, right? Because the square root of 4 is 2, so this just becomes 2i. And then because we're adding here, we can go ahead and just drop parentheses. Oh, I guess I don't really need that addition sign, but oh well. Negative 3 stays the same, plus over here, the negative underneath the radical comes out as an I, and then I can simplify the square root of 36, which is just 6. So this becomes 6i. And now again, I just combine like terms. So 2 and negative 3 gives me negative 1, negative 2i and positive 6i leaves me with a positive 4i. 2 for y'all to try at the bottom of the page. Go ahead and try those out, and then we'll go over them. All right, so on the first one, we're just adding, so we can drop the parentheses and just combine like terms. So negative 7 and positive 8 leaves me with a positive 1. Negative 3i and negative 9i gives me negative 12i, and we just leave it like that. On number 2, we had to do a little bit more work, right? Because we needed to simplify the radicals first. Both of them have a negative under the radical that needs to come out as an I, and then we can reduce each of them. 12 is 4 times 3, and 4 is 2 times 2. So I can bring a 2 out along with the I, and notice I'll be left with that 3 underneath the radical. Okay. On the second one over here that we're simplifying, that I comes out. 27 is 9 times 3, and then 9 is 3 times 3. So again, I can bring a 3 out along with that I. So I end up with 3i and then the square root of 3 because I had a 3 left over. Okay. And then I can go ahead and distribute this negative. So the first complex number over here, nothing's happening to it, so I can just drop parentheses. Over here, I have a negative that I need to distribute. So both of these terms become negative. And then again, I'm just combining like terms. So 5 and negative 3 give me 2. And then a positive 2i minus 3i square root of 3 leaves me with a negative I square root of 3. Okay. All right, so that's adding and subtracting. Now the last thing we want to look at, well, not the last thing, one of the last things we want to look at, we're going to look at multiplying complex numbers next. Okay, so again, same rule applies. Simplify the complex numbers as much as possible first, and then multiply. Once you've multiplied, combine like terms if you can. Okay, so on this one, we don't want to multiply straight across just yet. We want to take care of these i's, right? So I'm going to take each of those out. So this gives me I square root of 12 times I square root of 8. And then from here, you can do it 2 separate ways. You could either go ahead and multiply underneath the radicals now, or you could simplify each of these, and then whatever you get as the answer, you could multiply those together. I'm going to go ahead and simplify them individually because they're pretty easy to simplify, and then we'll see if we need to do more later. So 12 is the same thing as 3 times 4. 4 is 2 times 2. So I have 2 copies of a 2. So that means I can bring the 2 out, and I'm left with the 3 underneath. Okay. So this first one, I brought out a 2, and I'm bringing out this I. So I have 2i, and then what's left under my radical is just that 3. Okay. Now I want to look at the second one. The second one, I need to simplify the 8. 8 is 2 times 4, and 4 is 2 times 2. So here I have 2 copies of a 2 that I can bring out, and I'm going to be left with 1 copy of a 2 underneath my radical. So I brought out the 2 and I brought out the I, so I have a 2I, and then underneath the radical I still have a 2. Okay. And now that they're both simplified, now I'm going to go ahead and multiply them together. So when I multiply them together, I multiply number parts with numbers, i's with i's, radicals with radicals, right? So 2 times 2 gives me 4. I times I gives me I squared. And square root of 3 times square root of 2 gives me square root of 6. Okay? And then I want to simplify anything I can, which the square root of 3 does not simplify, right? It is a not prime number. It doesn't have 2 copies of a number within it, right? It's just 2 times 3, so I can't simplify that. However, I squared I can simplify, because remember, I squared is equal to -1. So I can replace this with a -1 and then keep going. Okay? So 4 times -1 is going to make this a -4 square root of 6. And then that's all we can do. Okay? All right, let's get another one. Same idea here. We're going to FOIL this time, or distribute over, under, right? And there's nothing to simplify ahead of time. Everything's already nice and pretty in its imaginary form, right? So I distribute my 2. 2 times -4 is going to give me -8. And then 2 times positive 6i is positive 12i. And then I'm going to distribute this -3i. -3i times -4 gives me a positive 12i. And I'm going to go ahead and just line it up under this other I term, just because then it's easy to combine. And then -3i times positive 6i gives me -18i squared. Okay? And then I just want to combine like terms. So I have my -8, I have positive 24i, and then remember this last term, I squared, remember, is -1. So I'm just going to replace my I squared with -1. -1 times that 18 is going to make it a positive 18. So I have -8 plus 24i plus 18. And then my last step is to go ahead and combine those 2 number parts. So I end up with a positive 10 plus 24i. And we just leave it like that. All right, let's look at one more. Same idea on this last one. The only difference is I have some simplifying to do before I get started, right? So underneath this radical, I can pull out the I, and I can simplify the square root of 9 to just be 3, right? So this first one is 2 minus 3i. On the second one, all I can do is pull out the I. I can't simplify square root of 3. So this one's going to be -3 plus I square root of 3. And now I can go ahead and start distributing, right? So when I distribute the 2, 2 times -3 gives me -6. 2 times I square root of 3 becomes a positive 2I square root of 3, right? And then I distribute this bottom one. -3i times -3 gives me a positive 9i. And then -3i times I square root of 3 gives me a -3i squared square root of 3. Okay. All right, and then I need to see if there's anything I can simplify. I can't really combine my 2 I terms because one has a radical and the other one doesn't. But I can simplify the I squared, which is a -1, right? So I get -6 plus 2I square root of 3 plus 9I, and this becomes a positive 3 square root of 3. Okay. Now again, you can't combine the -6 and the 3 square root of 3 because they're not like terms, because this one has a radical and this one doesn't. Same thing with the i's. So on exams or worksheets, I'm fine with you leaving it like this. There is a possibility, because my math lab likes you to enter answers as the real number piece plus the complex piece. And so if they give you boxes like this plus this I, then you'll have to enter those pieces individually. So notice what they're saying is we want the real number part in this box plus the imaginary part in this box. So the two pieces that don't have an I, you would put in here. So this would be like -6 plus 3 square root of 3. And then over in the I box, you would put these two terms. So you would have 2 square root of 3 plus I. Okay. Again, I'm not going to make you do that on an exam, but if my math lab gives you two separate boxes where one's already labeled with an I, make sure you put the two terms that have an I in this box and the ones that don't in this one. Does that make sense? All right. So on the next page, there are 3 for y'all to try. So go ahead and pause the video and give those a try, and then we'll go over them. All right, so when we look at this first one, we distribute the -7, which gives us -56 plus 63i, and then we distribute the -3i, which gives us -24i plus 27i squared. That I squared becomes a -1, right? Which then will make this 27 negative. So we combine the -27 and the -56, we end up with -83. And we combine our I terms, we should get 39i. Okay, everybody okay on that one? All right, then on the second one, we distribute, or before we distribute, excuse me, we simplify first, meaning we need to simplify these terms that have negative radicals, right? So square root of -16 becomes 4i, and square root of -9 becomes 3i. Once I've simplified those two pieces, then I can go ahead and start distributing. So when I distribute the 7 across, I get 14 plus 21i. When I distribute the -4i to those two terms, I get -8i and -12i squared. The I squared again becomes -1, which forces that 12 to be positive. And then positive 12 and the 14 I had out front combines to 26. And when we combine our I terms, we end up with 13i. Okay. All right. And then the last one I threw at you just to see if we remember. Okay. When we have a squared quantity, that means we do the quantity times itself. Okay. So don't just square the 4 and square the I. That's not going to give you the right answer. We have to write this out as -4 minus I, -4 minus I, because we have two copies of the exact same quantity. Okay, and then we can go ahead and distribute. So -4, when we distribute it, we're going to get a positive 16 and a positive 4i. And then when we distribute our negative I, we should get a positive 4i and a positive I squared. That I squared becomes a -1. So I combine the -1 with the 16, gives me 15. And when I combine my I terms, I get positive 8i. Okay, so we've talked about simplifying complex numbers. We've talked about adding and subtracting them, and then multiplying them. So the last thing we have to do is divide them. And when we divide complex numbers, we're actually not going to do any type of like long division or anything like that. What we're looking to do is create a fraction or rational expression that doesn't have an I in the denominator. So we introduced this idea of conjugates before when we were talking about radicals, right? When we were rationalizing the denominator. The same thing is true when we're dealing with complex numbers. We have what's called complex conjugates. And notice the only difference between these two complex numbers, or the complex number and its conjugate, is the sign in the middle. And the reason that we like this is because if we multiply a complex number times its conjugate number, all of our i's will cancel out. Okay, so I just want to show you how that works, and then we'll show you how we're going to apply it to our division. So here's an example. If I have a complex number 2 minus 3i, then its conjugate would be 2 plus 3i. And I just want to show you what happens when we multiply these out. Okay, if I distribute my 2, I'm going to get 4. And then when I distribute it to the 3i, I'm going to get a positive 6i. Okay, then I distribute my -3i, which gives me -6i, and -3i times positive 3i gives me -9i squared. Okay, so notice what happens is we're hoping to get rid of all of our i's, right? And we have a 4 out front. These I terms cancel because they're opposites, because of the opposite signs, right? And then here, even though I still have an I squared, remember I squared, this is -1. So if I do -1 times -9, that gives me a +9, and now this just becomes a nice little 13. Okay, so this is the idea we're going to use to be able to get these i's out of the denominator. All we're going to do is figure out what's the conjugate of the denominator, and we're just going to multiply that as a form of 1 so that we end up with a nice pretty number in the bottom instead of 1 with i's. Okay, so let's look at this first one. This first one, we have -3 over 4 minus 5i. So if I want to get rid of the i's in the denominator, I have to figure out what the conjugate is and multiply on top and bottom. Now, because we're trying to get rid of i's in the denominator is what I want to figure out the conjugate of. So 4 minus 5i means I need to multiply by a 4. That's not a 4. Let's try that again. We want to multiply by a 4 plus 5i. 4 plus 5i. And if I do it on the bottom, I got to do it on the top so that this is a form of 1, right? Okay, so I'm going to go ahead and just write this out so I can see it better because this is like super teeny tiny. All right, so we have -3 times 4 plus 5i on top, and on bottom we have 4 minus 5i times 4 plus 5i. Okay, so I just want to simplify this. So when I distribute on top, I'm going to get -12 and -15i, right? And now I want to distribute on the bottom. So when I distribute my 4 times 4 is 16. 4 times 5i is 20i. And then -5i times 4 is -20i. And -5i times -5i is -25i squared. Okay, so just like we expected, our I terms are going to cancel out here, right? And then this, remember, becomes a -1. So that means on top we have -12 minus 15i. On bottom we have the 16. And then when we turn this I squared into a -1, -1 times the -25 becomes a +25. So we end up with -12 minus 15i all over, what, 41? Okay. And then remember, when we're dealing with complex numbers, they want it written as 2 distinct terms, right? Like our boxes on the last page. So we need to have our real number part and then our part that's multiplied by I. So since this is all written as one expression, I just want to break it up. Okay. So this is the same as saying -12 over 41 minus 15 over 41i. That way we can see this is the real number part, right? And this is the imaginary part. And that's how we're going to want to enter our answer. Okay? Let me show you one more. Notice the only difference between this one and the last one we did is that it actually has a complex number on top too. Now, when you have a complex number on top and bottom, we are not guaranteed to get rid of all i's. So what we're focused on is getting rid of the i's in the denominator. So I'm going to look at the denominator and figure out what conjugate I need to multiply by. This is a 3 plus 4i, so I'm going to multiply by a 3 minus 4i. 3 minus 4i. Okay, and then I'm just going to rewrite it so I can see it a little bit bigger. So I have 6 plus 5i on top times 3 minus 4i. And on bottom, I have 3 plus 4i times 3 minus 4i. And then I just need to go ahead and multiply that out. So on top, I'm going to distribute my 6 first. 6 times 3 is 18. 6 times -4i is -24i. Then I'm going to distribute my 5i. 5i times 3 is 15i. And 5i times -4i is -20i squared. Okay. Then on bottom, I'm going to distribute my 3. 3 times 3 is 9. 3 times negative 4i is negative 12i. Then I'm going to move on to my 4i. 4i times 3 is a positive 12i. And 4i times negative 4i is negative 16i squared. And now we need to do some simplifying, right? My I terms are opposite on the bottom, so they cancel. And then both on the bottom and the top, I need to replace that I squared with a negative 1. Okay, so I'm just going to write what I have now. So on top, I have 18. And then I'm going to go ahead and combine negative 24 and 15 leaves me with negative 9i. And then since this I squared is a negative 1 times negative 20 makes that a positive 20. On bottom, I have the 9. And then when I replace my I squared with negative 1 times negative 16 makes that a positive 16. So I'm going to go ahead and combine the numbers on top and bottom. So on top, 18 and 20 gives me 38 minus 9i. All over 9 and 16 gives me 25. Okay? And then just like the last one, I want to go ahead and break it up into two distinct terms, right? So this is going to be 38 over 25 minus 9 over 25i. And obviously, if these fractions reduced, we definitely want to do that. In both of my examples, they weren't reducible, so we didn't do anything. But if you're able to reduce these fractions, please do so. Okay? All right, so there are 3 on the next page for you to try. And I believe I have a typo. Yes, number 3. Hopefully by the time you're watching this video, I fixed it. But number 3, we're going to replace with a different problem. Number 3, we're going to do negative 1 minus I over 7 plus 2i. So hopefully that's what's already on your paper, but if not, just go ahead and mark out number 3 and write this problem in. Okay? All right, pause the video, work those out. When you're ready, hit play, and we'll go over them. All right, let's see how you did. So on the first one, we're getting rid of the i's in the denominator, so we need the conjugate of 4 minus 5i, which would be 4 plus 5i. We multiply it on top and bottom. So when we distribute out the top, we should end up with 20 plus 25i. On bottom, when we distributed a number and its conjugate, the middle term should cancel. So we should just have the 16 and then the negative 25 from the end, which times I squared changes its sign to a positive 25. So when I combine 16 and 25 on the bottom, that gives me 41. And then we want to separate it into two distinct terms, right? Our real number term and our complex term. Okay. All right, let's look at the second one. Second one, same idea. We're trying to get rid of the I in the denominator. So we multiply by the denominator's conjugate, which in this case is 2 minus I. So we multiply by 2 minus I on top and bottom. On top, when we distribute the I into 2 minus I get 2I minus I squared. On bottom, when I multiply the complex number and its conjugate, I get a 4. My middle terms cancel, and I have a negative I squared. Now on top and bottom, I can replace both of those I squareds with negative 1s. So on top, I have 2I minus a negative 1, right? On bottom, I have the 4, and then this is negative 1, and there's a negative in front of it. So that's going to turn it into a positive 1. Okay, so 4 and 1 gives me a 5 on the bottom. On top, I simplify my double negatives, and then make sure you separate it into two distinct terms. Okay. All right, and then our last and final one, we're trying to get rid of the i's in the denominator. So the conjugate of 7 plus 2i would be 7 minus 2i, and we want to do that on top and bottom. So in this case, we're going to have to FOIL, right? Make sure you put parentheses around the top and bottom of your original expression so that you know to FOIL and not just multiply this by the I, right? Okay, so when we distribute all this out, on top we should end up with negative 7. We combine our I terms to get negative 5. And then we had a 2I squared. So I'm replacing I squared with negative 1. which means when I simplify this top piece, I should end up with negative 9 minus 5i. Okay. On bottom, when I multiply a number and its conjugate, I end up with the 49. My next two terms cancel out. And my last term, I'm left with negative 4i squared. I squared is negative 1, so that's going to turn that into a positive 4. And when I combine that positive 4 with the 49, I get 53. Okay. Again, make sure you separate it into two terms. All right. Okay, so that is the end of 3.1. So you should now be able to do that assignment in my math lab.